This is the second half of the lesson on linear inequalities. So if you haven't checked out the first video on this, do make sure you do that before you look at this one, or else it's not going to make a whole lot of sense. So all of the linear inequalities that we graphed in the first video all had something in common, which was that they were all less than or equal or greater than or equal, but we never saw ones where it was just less than or just greater than. And so the question should be, well, what difference does it make? So remember, the equals part was the line, right? So if we looked at, let's flip back for a second here. If we looked at this inequality, the equals part of this inequality was the actual line on the graph. So if we don't want to include the equals part, then that means we don't want to include the line. And so really the question is going to be, well, how are we going to show that? Because we have to draw the line in order to graph this thing. And so it's pretty easy. So when we do want to include the line, when we want to have less than or equal or greater than or equal, we do what we did last time, and we draw a solid line. But if we don't want to include it, so if we want to do just less than or just greater than, we draw a dotted line or a dashed line. And that's really the only difference. So it is something that you have to keep track of, because it's generally going to be easier to do that ahead of time instead of having to go back and erase parts of your line later. So let's try this out. We're going to graph y is greater than 3x plus 1. So we need a 5 by 5 grid. And then on this 5 by 5 grid, we need to mark our y-intercept, right, which is going to be at 1. And then we're going to use our slope, right? So 3 over 1, which means we're going to rise 3, run 1, which gets us another point there. Or we're going to go down 3 and left 1, which gets us points there and there. And so I don't have a clean way of drawing a dotted line on here. But for you, as you're putting your line through these points, don't just draw one solid line. Try to draw a dotted line. So something like this. Let me see if I can make that look a little bit nicer on my end. And so that's really the only difference. So if you understood everything from the last video, this shouldn't be too much harder for you. It's just something that you have to keep track of as you work to make sure that you're not missing it, especially if you're going quickly through your graphs. Erasing after the fact is a viable way of doing it. It's just a little bit time consuming, and it's hard to kind of get the corners, especially on an iPad. So there we go. This is what our inequality should look like. A dotted line instead of a solid line. But otherwise, there's not much change. So the next steps are exactly the same, where we're going to pick a point above the line and below the line. So probably maybe 0, 0, and 0, 2. And we're going to plug those in just like we did in the last video. So we've got 0, 0, 0, 2. Our inequality is y is greater than 3x plus 1. So if we plug those in, we end up with 0 is greater than 3 times 0 plus 1. Well, 3 times 0 is just 0, and 0 plus 1 is just 1, but 0 is not greater than 1, so we probably don't want that point. So if we try it again with the other one, again, the only thing that's going to change is the y value, so we're going to have 2 is greater than 3 times 0 plus 1. And we know what that whole right side of this inequality is going to work out to. So this is just going to be 2 is greater than 1. And that one is true. So we are going to shade the part of the graph that includes 0, 2, which is the top part. So this is pretty much the same thing, right? It's just a dotted line versus a solid line. It's the only difference. Keep in mind, in Math 10, you learned multiple different forms of linear equations. So you learned slope-intercept form, which is what this was. You learned slope-point form, which we're not going to get into. And you also learned standard form, which will come up from time to time. So I could also ask you to graph this. 2x minus 5y is greater than 10. There are different ways to graph this, but your best bet, and the one that pretty much everybody is going to go with, is just to convert this into slope-intercept form. So we're going to convert this to y equals mx plus b to make this a little bit more simple to graph. So if we want this to be in slope-intercept form, we got to think, okay, well, what's currently not where I want it to be? So we need the x's to be on the right, so let's start by doing that. We're going to subtract 2x on both sides to get the x's onto the right side of the inequality, which leaves me with negative 5y is greater than negative 2x plus 10. Then we want to move that negative 5, so we're going to divide all of our terms by negative 5. And we have to be really careful here. So if you think back to our radicals in chapter 5, when we divide both sides of an inequality by a negative number, like we did here, there's something we have to do to the inequality. So ask yourself, do you remember what that is? Hopefully you do. We need to flip our inequality. So we're changing the direction on it. So when you divide by a negative number on both sides, you got to flip the inequality. If you don't do that, you're going to get the complete opposite of the answer that you want. So it's a really easy thing to miss, but it's really crucial to pay attention to if you want to get the right answer. So there we are. Flip the inequality if you multiply or divide both sides by a negative number. So we've got our slope-intercept form. Y is less than 2/5 x minus 2. So we're ready to do some graphing. So we're going to get ourselves a 5x5 grid. And on this 5x5 grid, we have a y-intercept at negative 2 and a slope of 2/5. So we're going to go up 2 and right 5, or down 2 and left 5. And so we get these 3 points. So once again, this is just a less than, so there's no equals part of this inequality, which means we do want a dotted line. So make sure you've done a dotted line. And now we're ready to do some shading. So we've got to pick some points. There is something important that we'll need to think about here, though. So we're going to pick points probably at 0, 0, and maybe 0, negative 3. When you're plugging things in, you can't plug them into this. Or I mean, you can, but it's a very bad idea. So when plugging in your points, plug them back into the original equation. That will help you potentially avoid some mistakes. So if you've messed up while converting, you might be able to catch it by plugging it back into the right spot. So when plugging in points, use the original inequality. And that is something we're going to do at several points throughout this chapter. So it's something to get into the good habit of doing now. All right, so for our first point of 0, 0, our original inequality, remember, was 2x minus 5y is greater than 10. So if I plug in 0, 0, I've got 2 times 0 minus 5 times 0 is greater than 10. Which is going to get me, well, just a whole bunch of stuff that cancels out. So I've got 0 is greater than 10, which, hey, it's not. If I try 0, negative 3, I get 2 times 0 minus 5 times negative 3 is greater than 10. So that 2 times 0 is going to cancel out. The negative 5 times negative 3 is going to get me plus 15. And so that leaves me with 15 is greater than 10, which it is. So we want to include the part with 0, negative 3. So we're going to shade this bit down here on the bottom. And so there we are. We have converted it to a different form and graphed it, but we've made it work. So the last thing I want to do for this section is figure out how to go the other way. So if I give you an inequality, we want to be able to figure out what, if I give you a graph rather, we want to be able to figure out what inequality led to that graph, which is going to require us to figure out a couple of different things. All right, so here is our inequality. So there's going to be really 3 different things that we have to figure out here. The first is what is the equation of the line, right? We'll worry about the shading later, but if we can't get the line down, we're not going to be able to get any of this down. So step 1 is to write the equation of the line. And so to do that, we just need to figure out a couple of things, right? We need the slope and we need the y-intercept. Not every graph is going to be super clearly marked as far as points and labels go, But in this case, we can see if we look carefully that we've got a point here, a point there, and a point there that we can work with. And so our y-intercept is one of those points, which gives us a y-intercept of 1. And then our slope, if you just go from one point to the next and you figure out your rise and your run, our slope is 4 over 5. And so we end up with the equation y equals 4 over 5x plus 1. So that's the equation of the line. That's great. That's a huge part of this. Now we need to figure out which way we want the inequality to go. So to determine the inequality, we're going to pick a point and we're going to plug it in. But we actually only need to pick and plug in one point here because we only want a point from the shaded area. So this is something that people do tend to do wrong. We don't want a point from down here because that's not the part of our graph that we care about. We only care about the part of the graph that's shaded. So we're going to pick one point from this top area and we're going to plug that point in. And then we're just going to go with what makes the most sense based off of that. So you got to be really careful to make sure you're picking a point from the right part of the graph. Don't make yourself do extra work because it might just lead you to making a mistake. So if we look at our shaded part of our graph, we can pick anything from up there. Again, probably easiest to go with something that's along the y-axis. So I'm going to use point 0, 3. That's just me though. Any point from the shaded area will do. You could use the point 50, 100,000 and that would work. It wouldn't be a great choice, but it would. So to do this, we're going to write out our inequality, but we're just going to leave that center space blank. So we've got y, we've got 4/5 x plus 1, but we don't know what's going to go in here. That's what we're trying to find out. So we're going to plug in our point of 3 and 0. And we're going to simplify everything we can. So the 4/5 times 0 is just going to be 0. And the 0 plus 1 is just 1. And so now we're going to look at this and we're going to pick an inequality symbol that fits this. So pick the symbol that makes this statement at the end true. If we had used a point from the non-shaded area, we'd end up making the absolute wrong choice here. So that's why we want to make sure we use the right point. Once we've done that, we also have to decide whether our line is equal or not equal. So we just look to see if we had a solid or a dotted line here. So pick the right symbol and then check if the line is solid or dotted. So in our case, 3 is bigger than 1, so we're going to use the symbol that makes that true, right? 3 is larger than 1. And we had a solid line, so we do want the equals part of this. So 3 is greater than or equal to 1. And then the last thing we need to do is just write out the answer. So we end up with y is greater than or equal to 4/5 x plus 1. Right, so we just took the symbol that we figured out here and we plugged it into our inequality. Okay, so I'm going to give you one of these to try out for yourself. So go through the same process and see how it goes. And then once you're ready, come back and take a look. All right, so here's your inequality. So at this point, you want to try to figure out what the equation of this line is, what inequality symbol is going to make this work, and put it all together. So looking at our line, it looks like we've got a y-intercept at 3. So we've got y equals some slope, x plus 3. And then our slope, if you look carefully, it seems like it's at -1 over 2, right? So -1 over 2, -1 over 2. So that seems to be our slope. So we've got y equals -1 over 2x plus 3. So there's the equation of our line. Now we need to pick a point from the shaded area, which probably going to go with just 0, 0. We're going to plug that in. So if we plug that in here, we end up with 0 and -1/2 times 0 plus 3, which on the right side is all just going to end up coming out to 3. And so we've got 0 and 3. Well, 0 is less than 3, so we want to use this symbol, and that's a dotted line, so we don't want to include the equals part of this. We just want 0 and 3. Putting it all together, that gets us y is less than -1/2 x plus 3. And there we are. We've got our inequality. So I know I said this was the last thing, but there is one more quick thing I want to add in, which is just to talk about word problems a little bit. So let's write out a word problem, and then we'll talk about it. All right, so we've got student council selling hot dogs and hamburgers for a barbecue, and we're told a whole bunch of information, and we want to take all that information and turn it into an inequality. So looking at what we've got to think about a few things. We're told that a hot dog costs $2, so that's probably going to be helpful. We're told that a hamburger costs $3, so that's going to be helpful. And they want to make at least $120, so that's probably going to be helpful. Before we can even write this inequality, we probably want some variables. So let's figure out some variables that match up the things that we're dealing with here. So you got to ask yourself, well, what are the quantities that are changing? And that's going to be how many hot dogs we sell and how many hamburgers we sell. Try not to just use x and y. X and y are boring variables. They don't really tell you much. So for me, I'm going to say let b be hamburgers and let d be hot dogs. So those are my variables. And so now if a hot dog costs $2 and we spend a whole bunch, or we sell a whole bunch of hot dogs, then we're going to be making $2 times the number of hot dogs we sell. We're also going to be making $3.50 times the number of hamburgers we sell. And so that's how much money we're making. And we're told that we want to make at least $120. So the question really is what goes in this space here? And there's two key words that really define that question. And that is the words at least. So any question like this is going to have a couple of key words or a phrase that really kind of tells you what the inequality is. So in this case, if you want to make at least $120, that means that you can earn more than $120, not less, right? So we want to make greater than $120, not less than $120. At least also means that equaling is okay, right? So if you want to earn at least $120, if you land at exactly 120, that's okay. That's what you wanted. But if it said more than or less than or some kind of phrase like that, you got to really think about what these things mean. So when you're dealing with inequalities, read really carefully, pick out the best symbol that matches what you want, and think about it in terms of context, whether that actually makes sense. So there you are. That is linear inequalities. In the next video, we're going to do the same thing, but instead of doing lines, we're going to do it with parabolas. So once you're ready, switch on over to that and see how it goes.